We're told that this cubic equation has exactly one real root, and asked to show for this equation the Newton-Raphson formula can be written as given. Now, the general formula for the Newton-Raphson method is given in the formula book. Here it is. So it's when solving f of x equals 0, which is what we're doing here. This is going to be our f of x. And you can construct this little process. What's actually happening is that we have our function, we have our roots here that we're trying to find. We're putting an x value in. This is our starting x value. And then we find the gradient to that point. That's where the f dash x comes in. We follow the tangent down until we hit the x-axis again. That becomes our new value of x. We repeat the process and we just get closer and closer to the root. You can just keep putting it into this iterative formula. Okay, and it's possible to derive it using this idea. So we need to do it for our f of x, which means we've got f dash x equal to 6x squared plus 2x. I've just differentiated 2x cubed plus x squared minus 1. And therefore we've got xn plus 1 is going to be xn minus f of xn. So that's going to be the 2x cubed plus x squared minus 1, just with little n's on the x, because to show that it's like the first x value or the second x value and so on, divided by this derivative, which we just worked out, 6x squared plus 2x, just with little n's on as well. So we've got the denominator there, but we don't have it as a single fraction. We've got this xn, so we're going to need to put it over a common denominator. I can times the xn by 6xn squared plus 2xn over 6xn squared plus 2xn. So now I can combine the fractions. I'm going to multiply this bracket out, so I'll get 6xn cubed plus 2xn squared. Then you got to treat this as like a bracket really when you bring it together. So I'm actually going to get minus 2xn cubed and then minus xn squared. Okay, even though there's a plus there, I'm minusing the whole thing, but then I'm going to get a plus 1. So just be careful with that bit. Right, and now I can combine the x cubed terms. So 4xn cubed. I've got 2xn squared minus xn squared, so that'd be plus xn squared, and then a plus 1. Okay, so that is the Newton-Raphson formula when written as a single fraction for our particular function. Let's just check. So we had 4, 1, and 1, and it does agree well, so that's really good. Whereas to use the formula given that we've actually derived ourselves with x1 equal to 1 to find x2 and x3. So here's how you do this. You put 1 into your calculator as your answer, and then it's going to be the fraction. Replace all of your xn's by answer. This will create a natural iterative process. So I'm putting in 1 and I'm going to get out 3/4. The great thing about this is that now that is my answer. So if I press equals again, it'll give me my next iteration, 2/3. And that's all we need to do for this question. Just away from the question, let's just see what we actually get when we... So it actually converges pretty quickly. Once we got to 2, like 3/4 was quite far away, but once we got to 2/3, I mean, it's all relative, I guess, but it feels quite close, and it only took a couple more iterations to get this exactly. So you can see, from my graph, it's like we started off quite far away, but then we got pretty close and then very close and just closer and closer. So finally, explain why for this question, the Newton-Raphson method cannot be used with x1 equals 0. If you try putting it in to your calculator, you get a math error. The reason being is that the denominator will also be 0. You can't actually ever have f dash x equaling 0, and it is here. So I'm going to write down um, maybe I'll write down f dash 0 is equal to 0. So x2 will not be defined. Now the question wants a little bit more than that. They want to know like why, what is the physical reason going on? And if you think back to the graph, let's say I've got like this kind of curve. See, if I start my Newton-Raphson method here, I'm okay because it's going to converge towards it. If I started maybe up here, then I'd end up going all the way over here. Like we could get quite far away. But if I actually start and by the way, that's just the left of the stationary point. If I then start at this point here, actually, it would be horizontal. It would never meet the x-axis. So the answers just want something along the lines of, yeah, there will be a stationary point. There is a stationary point at x equals 0. Is one flaw with this method. You need to have a good starting value. Again, it could take a long time to converge as well if you have a poor starting value, but definitely it would never converge if you start at a stationary point. Other things you could say are that the tangent is going to be horizontal, or that it's never going to meet the x-axis. Right.